Good day to all. Today we are going to see about the classes of motor duty. What are all the classes of motor duty? First one is continuous duty, then short time duty, then intermediate periodic duty with starting, intermediate periodic duty with starting and breaking, and continuous duty with intermediate period loading, continuous duty with starting and breaking, then continuous duty with the periodic speed change. Now we will go deeply for these classes of motor duty. First one is continuous duty. Continuous duty. This duty is denotes that the motor is running long enough and the electrical motor temperature reaches a steady state value. These motors are used in paper mill drives, compressors or conveyors, etc. See, this continuous duty means motor is continuously running. There is a no rest in that motor. Always it's running. If you are going for conveyor, whether it is in the production industry or it is in the airport, if you are seeing the conveyor belt is running always. If it is the production industry also, the conveyor belt is running always. Then some material come over here in that conveyor belt. There's some materials will come over here, then it will stop some over here still, but the conveyor is running, so there is a no rest in that. That is called continuous duty motors. That example is paper mill drives also have a continuous motor duty, as well as the compressors and conveyors. This is the waveform of that continuous duty with the load, torque and time. See, you can see here the load, torque and time have a straight path because of this continuous duty, and the curve between the theta as well as the time, it slightly increase and it will have some stated value. That is this steady state condition. Then again we'll go for the short time duty. In this motors, the time of that operation is very low and the heating time is much lower than the cooling time. Whereas in this continuous duty, cooling time is much higher than the heating time, because it's that motor is always running, so heating is more in that particular motor. Whereas here it's a heating time is much lower than the cooling time, because it's a short time duty, it's running only short time. So the motor cooks off to ambient temperature before operating again. These motors are used in crane drives for the household appliances, valves, drives and etc. The best example here is the household appliances, means we can take it as a mixie. In our home itself we are using that mixie. In that mixie, in our home we'll use that mixie for a certain before 1 minute, I think. If you want to uh, have that coconut inside that mixie, we will do that operation with a certain time within 30 seconds, I think so. So that is the short term working appliances. That is household appliances we use for the short time duty. That is the best example of short time duty motors. This is the curve for that short time motor duty. See, you can see here the load torque is high and the time certainly it's down for 0, because this is the running time. Then it will get 0. As well as you can see here theta will increase slightly, then it will decrease. This decreasing time is called the motor is in off state. This is the short time duty of that motor. Then the intermediate periodic duty. Here the motor operates for some time and then there is a rest period. In both cases the time is insufficient to rise the temperature to to steady state value or cool it off to ambient temperature. This is seen at a press and a drilling machine drives, etc. See, if you are going for a drilling machine, in the drilling machine the motor runs sometimes, then it will have some rest some more time, then again it will run. Likewise, if you are seeing that many of the motors, they'll have application like we want to start the motor and running sometime, then we will have a rest, then it should run like that. That is called intermediate perioding of duty. This is the waveform of that intermediate duty. See here, this is the on state, then this is the off state, then this is the again on state, then this is the off state, this is on state. If you are going for that theta to time, it is slightly increase, then it will going to decrease in that off state, then again it will increase in that on state, then again it will decrease in that off state. Likewise, it will happen according to that load torque and time. This is the intermediate duty. Then intermediate duty with starting. In this step of duty, there is a period of starting which cannot be ignored, and if there is a heat losses at the time. After that, there is a running period and rest period which are not adequate to attain the steady state temperatures. This motor duty class is widely used in metal cutting and drilling tool drives, mine hose, etc. For that metal cutting, here is the best example. In that metal cutting, we will have this intermediate period duty with the starting one. This is the example of this intermediate duty with the starting. This is the graph for that T torque and time. This is the starting stage and this is the running stage. Then we'll have a rest here. There is no running over here. Then again it's running and it'll have a slight decrease. Then it will go to stop. Likewise, the curve will become a theta to T also. This is the intermediate with the starting conditions. Again, intermediate period during with starting and braking also. See, in this type of drives, heat loss during starting and braking cannot be ignored because it will have a starting as well as braking will happen in that heat loss over here. So, the corresponding periods are starting period, operating period, braking period and the resting period. This is called intermediate periodic duty with the starting and the braking. This is the waveform. See, if it is that intermediate starting, then the waveform like this. Then if it is braking, it will go for the reverse direction, so it will go to the negative. Likewise, after that it will have a rest. There is a no running stage. Then it will again starting. Then it will go for braking. Vice versa, it will happen. The same thing will go for that theta also. See, it will have a increase over, then if it is resting stage, then it will decrease, again it will increase when the motor is starting. According to that, it will running. Then the continuous duty with the intermediate periodic loading. See, in this type of motor, everything is same as the periodic duty, but there is a no load running period occurs instead of rest period. Where there is a rest period, here there is a no load running period instead of rest period. Pressing and cutting are the example of this system of this continuous duty with the intermediate periodic loading. Then the continuous duty with the starting and braking, it is also the period of starting and running and braking, and there is a no resting period. The main drive blooming is an example of this continuous duty with starting and braking. Then the final one is continuous duty with the periodic speed changes. In this type of motor, there are different running periods at different loads and speeds. Depending upon the loads and speeds, it will have the running period, different running period. But there is a no rest period, and all other periods are too short to attain the steady state temperatures. These are all about the continuous class duty and overall classes of motor duty. Thank you.